Welcome everyone to our YouTube channel. In the following series of tutorials, we are going to be looking at sequences and series. We're going to look at the different types of series and sequences, and we're going to look at the fundamental principles or concepts that are going to allow you to master your techniques to solve them effortlessly. So grab your favorite notebooks, pencil, and let's get started. So to begin with, let's try to understand the difference between series and sequences. So a sequence is simply an ordered list of numbers, while a series is the sum of those numbers in a sequence. So for example, if we have a sequence 2, 4, 6, 8, 10, the series will therefore be 2 plus 4 plus 6 plus 8 plus 10. Okay, so in general, that's the basic understanding between series and sequences. However, there are different types of series and sequences, as we have already talked about in the introduction, and we're going to look at the each and every one of those types of sequences and series that we find. And to begin with, we're going to start with the arithmetic sequences. So arithmetic sequences are basically one of the most common types of sequences, and we're going to learn how to identify them and calculate their common differences, and eventually we're going to look at the series, or rather the arithmetic series. So to do this, we're going to just look at various examples and how we can then approach these examples to determine whether if it is an arithmetic sequence, a geometric sequence, and what kind of questions would they ask you. Okay. So here are our examples. And the first example asks us, the general term of a sequence is 3n plus 1. Determine the first 3 terms in this sequence. So to begin with, when dealing with arithmetic sequences, as you probably already know, the general term, or the Tn, however it can also be Tk, Tc, the subscript does not really matter that much. However, Tn is the commonly used subscript. So for an arithmetic sequence, the general term is given by Tn equals to a plus n n minus 1 multiplied by d. Okay, and a is the first term of the sequence, d is the common difference, and n is the number of terms. So for example, if we look at our previous sequence where we had 2, 4, 6, 8, 10, the a value will be 2, so this will be a. Okay, so a is the first term of the sequence, and then the difference between the 2 subsequent terms is what we refer as to the common difference, or d. And it is important to remember that in an arithmetic sequence, the common difference is always the same, okay, between 2 consecutive terms. So if, let's say for example, d was equals to 2, That means for every subsequent terms, or yes, subsequent terms, the common difference should always be 2. So between 4 and 6, it's also going to be 2. Between 6 and 8, it's also going to be 2. And between 8 and 10, it's also going to be 2. Okay, so that is the general principle. So our question was asking us to find the general term of the sequence to determine the first 3 terms, given that the general sequence equals to 3n plus 1. Okay, so how do we go about that? So we're just going to write the information that we are given. So Tn, which is the general term, is given as 3n plus 1. And to get the first 3 terms, remember n is the number of terms. So you simply substitute the number that is required. Okay, so for T1, that is the first term, you simply substitute 1 where there's n. So it becomes 3 into 1 plus 1. And when you calculate that, that will be 4. So in other words, we're saying that T1 equals to 4 if we let n equals to 1. Okay, so if we let n equals to 1, which is the first term, the general term, or rather T1, will be equal to 4. So we can do that for the remaining terms that they want. So for T2, we simply substitute 2 where there's n, and you're going to get 7. Therefore, we're saying that T2 equals to 7. The same goes for the third term. Therefore, T3 equals to 10. So we're saying the first 3 terms of this sequence is going to be 4, 7, and 10. Okay, and it is always good to check if it's correct. As you already know, the constant difference between the 2 consecutive terms of an arithmetic sequence is supposed to be common. Okay, so we can just check that by subtracting 2 consecutive terms in our sequence. So for example, 7 minus 4 equals to 3, and 10 minus 7 equals to 3. So we can clearly see that there is a common difference in this sequence. Therefore, it is true that this is actually an arithmetic sequence, and our calculation is also correct. Okay, so it is always good to check whether your answer was correct by checking if the common difference is actually common between 2 consecutive terms of the sequence that you have calculated. Okay, I hope you understand that. So looking at the second example, we are asked to consider the sequence 2, 5, 8, and 11, and then determine the general term of the sequence. Okay, so remember the general term is the formula for the specific sequence that you're dealing with. So for our sequence, we have 2, 5, 8, and 11. Okay, so we can check if it is an arithmetic sequence like we did before by looking looking at the common difference, or whether if there is a common difference between two consecutive terms. So in this case, if we subtract 5 minus 2, we know that it should be equal to 8 minus 5, and it should also be equal to 11 minus 8 for it to be in arithmetic sequence. And if we do that, you'll find that there is going to be a common difference, which is 3. Okay, so therefore D in this sequence equals to 3. And if you remember from the intro, we did say that for an arithmetic sequence, right, the general term is given by Tn equals to A, which is the first term of the sequence, plus n minus 1 in brackets multiplied by D. We already know that the first term is 2, so A equals to 2. Okay, since we already know that, we can substitute them into the equation. So we can say, therefore, for the general term Tn, A is 2 plus n minus 1, where D equals to 3. Okay, then we can expand the equation such that Tn equals to 2 plus 3n minus 3. And if we calculate that, we get 3n 2 subtract -3, that equals to 1. Okay, so the general term for our sequence equals to Tn equals to 3n minus 1. Okay, so when the general term of a sequence is given, we know that each term of the sequence can be determined by substituting n into the general term. Okay, so in this sequence we had how many terms? We had 1, 2, 3, 4 terms. Okay, so let's say, for example, they wanted us to calculate the 6th term or the 8th term. They can simply substitute the term that they want in place of n, as we already know that n represents the number of terms. Okay, so that was example 2. We're going to move to the third example. Okay, so in example 3, we are told that the 5th term of an arithmetic sequence is 0, and then the 13th term of the sequence is 16. First, determine the common difference, then determine the first term and the 21st term. Okay, so we are just first going to write down the information that we already know. Okay, so we know that the 5th term, right, that is T5 is equals to 0, right? We already given, and from, okay, so that is that, and also are given that the 13th term, which is T13, is equals to 16, and we are supposed to determine the common difference, and we know the common difference is the number between two consecutive terms in an arithmetic sequence. However, we know that 5 and 13 are not really consecutive. So what we can do is that we can try to find a general equation for our given terms. Okay, so for T5, if you consider T5, we're going to say for Tn equals to A plus n into 1 plus d. I'm going to let n equals to 5 because we know the value of the fifth term. So T5 equals to 0, and we have A plus n equals to 5, and we have d. Therefore, we end up with an equation like this, where we have A plus 5 minus 1 equals to 4 plus 4d. Okay, and we can rearrange that such that we have A, right, equals to 0 minus 4d, or we can simply leave it like that. Okay, so this will be our equation 1. On the other end, we can also consider T13. So if we let n equals to 13, we end up with let n equals to 13, we have 16 equals to A plus 13 minus 1 into d. 16 equals to A 13 minus 1, that's 12, times d plus 12d. Okay, so we can leave it like that, such that this is equation 2. Okay, so in order for us to solve the unknown value, we can use that subtraction of equations, or simultaneous equation subtraction. Okay, so we are going to say subtract equation 2 from 1. Okay, if we do that, we end up with A plus 4d, which is this equation, equals to 0. That is equation 1. And we have the second equation, which is A plus 12d equals to 16, which is equation 2. Okay, so if we do that, we are subtracting 1 from 2, and the whole idea is to try to eliminate one variable. Okay, in this case, the variable that we can eliminate is A. Okay, so if we subtract these values, what we're going to find out is that A and A are going to cancel. Okay, and are going to end up with 4d subtract 12d, and what we get is negative 8d. Okay, equals to 0 minus 16, negative 16. Okay, we can then divide by negative 8 on both sides, such that we end up with d equals to 2. Okay, so we divided by negative 8 on both sides. So the common difference in this case equals to 2. Okay, so that is the first part of our question. Remember, they ask us the common difference. Okay, so moving on to the second part, which is asking us to calculate the first term. Okay, so calculate A. So it is fairly simple. As you already have the common difference, we can simply substitute 2 into either equation 1 or equation 2. And if we do that for simplicity, we can use equation A, such that A equals to negative 4D. Okay, and now going to substitute 2. Okay, because you know that D equals to 2, so A equals to 0 minus 4 2, which is equals to negative 4 multiplied by 2, that is going to give you negative 8. Okay, so the value of A is negative 8, and you know that A is the first term of the sequence, so the first term, or T1, equals to negative 8. Okay, so the last question was to calculate the 21st term, and like we previously said, if you have the general term and you're asked to calculate a term that is not in the sequence, to simply substitute the term which is n into the general formula or the general term. So let's construct the general term, since we already have the value of A and the value of D. Okay, so this will be 3.3. So we know that Tn, which is the general term, is equals to A plus into bracket negative 1, n minus negative 1 equals to D. Tn, we know that A equals to negative 8, n minus 1, and we know that D equals to 2. So if we simplify that, we end up with negative 8 plus 2n minus 2, end up with 2n, negative 8 minus 2, that gives us negative 10. Okay, so that is our general formula for our sequence. Okay, so now we're going to let n equals to 21, since they want us to calculate the 21st term. So if we do that, T21 is going to be equal to 221 minus 10. And if we calculate that, what you're going to get is 32. Okay, you can do that on your calculator. So we have 221 minus 10, then you get 22. Okay, so that was the third example, how to determine the common difference, the first term and the 21st term. In other words, what they're trying to ask us is to determine the general formula for the sequence. So moving forward, for the example, the second from last, which term of the sequence 15, 13, 11, 9, and 7 will be equal to negative 23? Okay, so in this question, what they're trying to ask us is to determine the value of n. Okay, so how do we go about that? So the first thing that you have to do is first determine the general formula. Okay, so in the sequence 15, 13, 11, 9, and 7, what we are looking for is n, given that Tn will be equal to negative 23. Okay, so the general formula is Tn a into n minus 1 into d. So we first look to see if it's an arithmetic sequence by looking at the two consecutive terms to see if there is a common difference. And if you do that, you're going to find that the common difference is going to be negative 2. Okay, so 13 minus 15, that's going to be negative 2. 13, 11 minus 13, again negative 2. 11, 9 minus 11, negative 2. 7, 9, negative 2. Therefore, we know that the common difference d equals to negative 2. Okay, and a is the first term of the sequence, and the first term in this sequence is 15. Okay, so the general term for sequence will be 15 plus n minus 1 minus negative 2. So be careful when you multiply into the brackets when you have a negative value, and take off this negative. So 15 plus, as was mentioned, so negative 2 multiplied by positive n, that will give you negative 2n. Okay, then negative 2 multiplied by negative 1, that's positive 2. We open the brackets, we end up with 15. Sorry about that, my bad. Minus 2n plus 2, because we are multiplying by a positive, such that the general term is equals to negative 2n. 15 plus 2, that's 17. So 17. So that is our general term, negative 2n plus 17. So we're saying that if Tn equals to negative 23, what is the value of n? So you simply substitute to calculate the unknown value. So negative 23 is equals to negative 2n plus 17. We can move these values to that side such that we have 2n, right? We moved 2n to this side, and we're going to move 23 to that side. Okay, so if 2n equals to 17 plus 23. Okay, 2n is going to be equal to 17 plus 23, that's 40. So n equals to 20. Okay, so that is the final answer. In other words, you're saying T20 is equals to negative 23. Okay, so I hope you understood that. If you have any question, please feel free to leave your questions in the comment section. Okay, so the last question, or rather the last example before we finish off, is as follows. So you're given these terms: 2k minus 1, k plus 3, and 3k plus 1 are the first three terms of an arithmetic sequence. So in this example, you're already told that it is an arithmetic sequence, and in your mind you should be ringing, oh, that means then the difference between two consecutive terms is supposed to be equal. Okay, so that is d. right? We have a common difference between the two consecutive terms of this sequence. Okay, so it is going to be a bit well, it's not really difficult, but it just wants you to understand, okay, the concept of the common difference. So now that we have established that, let's see how do we then approach it. Okay, so we have 2k minus 1, that is the first term, and we have k plus 3, that is the second term, and then the third term equals to 3k plus 1. Okay, and you are not told that this is an arithmetic sequence. That means if we subtract k plus 3 and 2k minus 1, we are supposed to get the value of d. Okay, and that also means that if we subtract 3k plus 1 minus 3k, sorry, 3 plus k plus 3, we're supposed to get d. And we know that for an arithmetic sequence, the value of d is supposed to be the same. Okay, that is the common difference. Therefore, we can say that k plus 3 in brackets minus 2k minus 1 is equal to 3k plus 1, right, minus k plus 3. Okay, so that is the common difference. We know the common difference is supposed to be the same. So we can now expand the brackets such that we have k plus 3 negative 2k plus 1 is equal to 3k plus 1 minus k minus 3. Okay, we can try to sort out one side at a time. So in this case, we are going to have k minus 2k. This gives us negative k. 3 plus 1, 4. 3k minus k, we have 2k. 1 minus 3, we have negative 2. Okay, so we'd like to keep the variable positive, so we're going to move negative k to the other side, then negative 2 to the other side. Okay, so if we do that, we get 4 plus 2 equals to 2k plus k. Okay, we simplify that, we have 6, and we have 3k, and therefore we substitute, we subdivide by 3 such that k equals to 2. Okay, so that is the value of k. Okay, and the last question asks us to determine the 11th term. Okay, so how do you then go about that? So now that we have the value of k, we can then substitute the value of k into our sequence to see the actual values of the actual terms. Okay, so for t1, t2, and t3, okay, we're going to say 2k minus 1, that is 2 minus 1, which is equals to 4 minus 1 equals to 3. Okay, so the first term is 3, the second term is k plus 3, which equals to 2 plus 3, which equals to 5. Okay, and then the third term is 3k plus 1, which equals to 3 into k, which is 2 plus 1, and if you calculate that, you get 7. Okay, so the sequence is therefore 3, 5, 7. You already know that a is the value of the first term, so that is the value of a. We established that d equals to 2. Remember, when we started off with this equation, right? That means this side is d and that side is d. Okay, so by doing that, if we think about it, since we are basically dealing with d as value, that means also that value of k equals to d. But you can also check it out from this sequence by then subtracting the two consecutive terms. So 5 minus 3 equals to 2, then 7 minus 3 equals to 2. As you can see, the value of d equals to 2. Okay, so if you move forward, we're going to say, okay, Tn equals to a plus n minus 1 equals to d, where we have a equals to 3, then n minus 1 equals to 2. Okay, so we are supposed to calculate the 11th term. So okay, so let's just simplify that. So we have 3 plus 2n minus 2, then we have 2n plus 1. Okay, so that is our general term. So the general term was to 2n plus 1. Okay, so what is T11? Like we already said previously, you simply substitute the 11 with this n. So in this case, it goes to be 2 into 11 plus 1. And if you do that, we are going to get 22 plus 1, which equals to 23. Okay, so that is the value of the 11th term. So the value of the 11th term is 23. Okay, so I hope that was helpful. If you do like it, please feel free to like, comment and subscribe, and then look out for more videos on sequences and series. And the next time we're going to be looking at geometric sequences. So for your practice, try out these following questions. Okay, so question 1, we have an arithmetic sequence, right? Where the first term goes to -1 and the seventh term goes to 35, and you're supposed to determine the common difference and then the number of terms if the last term of the sequence is 473. And then the second question is, which term of the arithmetic sequence -2, 3, 8 is going to be equal to 493? Okay, so let me know in the comment section how it goes, and we'll see each other next time. Thank you.